Hi, I am Bhavik Thakkar. Welcome to Btitude. If you're more comfortable with Hindi language, please hit the I button and it will take you to the Hindi version of the exact same video. But if you are comfortable with English, let's carry on. Well, in this video, we are going to learn how exactly can we find the remainders, because these questions are asked in various competitive examinations. Now, in case you know how we can find out the remainder when 6 raised to 7 raised to 283 is divided by 11, or if you know how to find the remainder when 21 raised to 962 is divided by 221, and if you know how to find remainder when 3 raised to 90 is divided by 34, then this video is not for you. You can simply off this video and do whatever you want to do. Just don't trouble your parents, because they have been troubled since they have given birth to you, right? So, in case you don't know how to find it out and if you are eager to learn, let's get started. Let us now understand what are the basic fundamentals, I mean those theory which will help us finding the remainders. Fine. So, there are basically three concepts that we are going to learn in this particular video. The first one is concept of cyclicity. So, this is the basic concept. Without this, you cannot find the remainders. So, this is the first concept, and obviously there is another one, that is remainder theorem. So, once you know both of these things, and then when you know how to combine them, that is where you can find the remainders. Fine. But this is the traditional method. Now, here I have come up with one additional method, that is Torsion method. Now, the thing is that these two are obviously necessary. This method will work as a shortcut, but knowing these two fundamentals, those two theories is very important. Alright. So, we will know each of these three in this particular video. Alright. So, let's start with the concept of cyclicity. So, what does cyclicity exactly mean? Alright. Okay. Have a look at this particular number sequence. Can you figure it out any pattern whatsoever? Of course you can, right? The thing is that these 6 terms, right, these 6 numbers are getting repeated after each and every cycle. Can you understand cyclicity, right? So, what does cycle means? When the same thing comes again and again, right? So, the same 6 terms are coming again and again. So, this is what the cyclicity is, and if you are able to understand the pattern of cyclicity, it will be easier for us to answer this kind of the questions, right? Like in this world, what would be 5678th term, right? So, obviously we are not going to write all the way up to 5678, we would use some logic. The logic is pretty easy if you can understand the first term, because these are the same 6 terms, right? So, this term will be one of these, right? It's pretty easy to understand, right? Now, if you understand, first term will be 3, second term will be 5, third term will be 6, fourth term will be 8, fifth term will be 9, sixth term will be 2, right? As you can see, and since 7th term again will be 3, 8th term again will be 5, 9th term again will be 6, 10th, 11th, 12th, 13, 14, 15, 16, 17 and 18th term will again be 2. Are you getting the pattern? And there, like that, we will go on and on and on, right? Are you able to understand the pattern? The pattern is the cycle completes at a multiple of 6, because there are 6 terms. So, how we can find out this? All you have to do is to divide this by 6. So, that would give us number of cycles completed, right? So, if you are able to find out the remainder, when you divide 5678 divided by 6, what will be the remainder? Obviously, 6 9s are 54, 2 will be the remainder, 27, 6 4s are 24, 3 will be the remainder, 38, 6 6 are 36, 2 will be the remainder. So, this remainder would be 2. Now, what does this mean? This means that certain cycles are completed, of 6 are completed, but 2 extra numbers are there in 5678. So whenever it will be completed, it will end at 2 extra terms, that means first, second. 5 should be your answer. Are you getting this? So don't just mug up the method, try to visualize it. Once you visualize it, it is very easy, and I think we can understand this, right? Pretty easy to understand this. So this is the concept of cyclicity. Second one, remainder theorem. So here we are supposed to understand what exactly is the remainder theorem and how exactly it works. Alright? Alright, then first thing, what remainder theorem means? Let's try to understand. For example, if we are supposed to find out remainder when for example, this whole number, so it will 2851 multiplied by this plus this and this multiplication, this addition will be a big number. And when this whole number is divided by, say for example 11, and we are supposed to find out the remainder, obviously you can do it, this multiplied by this multiplied by this, you can add them and find the remainder, but that would take lot of time, right? And that is where remainder theorem comes into the picture. Remainder theorem is a shortcut, alright? It is a shortcut which will help us finding a remainder when the numbers are having multiplication or addition kind of relationship. Alright, for example here, now let us understand how exactly this remainder theorem works, right? It's the same question. If we are supposed to find out the remainder, how does it work? So remainder theorem says you are not supposed to take the numbers as they are. The shortcut is you can take simply the remainders. So instead of taking the whole big numbers, you can simply take the remainders. How will you do that? Obviously you can divide the numbers individually. That means 11 2s are 22, 6 65, 10 101, 99. So 2 is the remainder, right? So 2, you can actually just write 2 for this whole number, because when this number is divided by 11, remainder is 2. Are you getting it? Again, when you divide this number by 11, 11 3s are 33, 5 50, 44 6, 69 3. So and multiplication, then just multiply. Are you getting it? That is the shortcut. That is what remainder theorem says. Instead of number, you can just take those remainders, and that's about it. If you are supposed to find remainders, of course, right? Now here 11 4s are 44, 119, 881, 77 4. And here it should be 11 7s are 77, 10 105, 99 6, 69 3. Alright, and there was addition symbol in between, so it becomes 6 plus 12, 18 divided by 11, the remainder will be 7, right? When 18 is divided by 11, remainder will be 7. That's about it. Are you getting this method? That is of course a big shortcut, right? You are not supposed to multiply these big numbers 2 times. That would have simply killed our time. And then also we would have get such a big number that even dividing by 11 would have taken time. Now here another thing, if you have actually watched my video of how to find remainders by rules for divisibility, that would also help. Like for certain numbers, we should be knowing the rules for divisibility. If you know, it's even easier. Here 1 plus 8 is 9, 9 minus 7 is 2. So you can directly do it. You don't have to even do it manually. If you know the rule, alternate numbers, 1 plus 8 is 9 minus 7, that is 2. Alternate number, 9 plus 8 is 17 minus 3, 14, but don't write 14. The remainder cannot be bigger than the number. So 14 divided by 11, remainder will be 3, right? Here 1 plus 5 is 6, 4 plus 9 is 13, 6 minus 13 is minus 7. But minus 7 is nothing but 11 minus 7, because we are dividing by 11, right? So minus 7 can be taken as 11 minus 7, that is 4 as well. This is something that I have already explained how and why. We can also understand the remainder in negative terms like minus 7, but while answering, like for example, just let me give you an idea about it, alright. For example, 15, when divided by 11, you can say 11 ones are 11, 4 is the remainder, or you can say 15 divided by 11, 11 2s are 22, minus 7 is the remainder. Both are same. Are you getting this? You can do it like this as well, right? 11 2s are not practically, we don't say like that, but this, then you can understand minus 7 plus 11 will be 4. That way we can convert it. That is exactly what I did here, right? Alright, then here 9 plus 7, 16, minus 8 plus 5, 13, 16 minus 13 is 3. So that would be the easier way to find the remainders as well. Rules for divisibility. Fine. If you haven't watched it, I'm giving you the I button. Please watch that video. That is also going to help you. Alright then, remainder theorem is also clear now, right? Now, as such, we are supposed to know the third rule as well, that is Totient method. Now, this is very unique method and this is going to help you. But first, let us try some questions with the use of only two basic rules, because that is basic, right? Once the basic is clear, then we will understand how Totient method will prove to be a good shortcut. Alright then, let's have a look at the first question. Look, in case you have got an idea, you can actually work it out on your own first as well by pausing the video, or else I'll simply remove this Hindi version. Let's understand how we can understand this. Alright, here, can I take this whole question as 347 multiplied by 347 multiplied by 347 multiplied by 347 times, right? Alright, and when this one is divided by 7, what would be the remainder? That is what we are supposed to find out. Now, first thing first, when we are supposed to find out remainder, what did remainder theorem say? It says that instead of numbers, you can simply put the remainders. That is the first shortcut. So, 7 4s are 28, 6 67, 7 9s are 63, 4 is the remainder. So, instead of 347, you can put 4, 4, 4, 4. So, this number actually becomes 4 raised to 347. Good enough? Good enough? Now, don't convert these 347 as 4 as well, right? It is not 347. It is 4 into 4 for 347 times. Okay, there is a difference. 347 is not a number. Number is always 4. 4 into 4 into 4, or 347, 347, 347, 4 347 times. So, don't do that thing with the power. Alright? Okay. So, now try to understand. Of course, we cannot do it in exam. It's not practically possible, right? 4 raised to 347 will take lots of time. So, what does that mean is, there has to be a cycle. There has to be a cyclic pattern. So, once you know there is a cyclic pattern, then you don't have to go up to 347th term, right? So, now let's try to figure it out. First power is 4. When 4 is divided by 7, obviously you cannot divide, so 4 itself is the remainder. So, your remainder is 4. Now, next, when it is 4 into 4, that becomes 16, and 16 when divided by 7, 7 2s are 14, so 2 is the remainder. So, now we are trying to understand what is the pattern of remainders. Because we are supposed to find out remainders, we are trying to find out the cycle of remainders. Okay, so we are just listing the remainders as we are getting it. So, 4, then 4 4s are 16 divided by 7, so I would say 2, right? So, instead of these 2 4s, I can now put 2. 2 4s are 8. 8 divided by 7 is 1 is the remainder, so I can put 1. So, instead of this 2 and 4, I can put 1. 1 into 4, 4. That means again there comes 4. Are you getting it? That means it is a cycle of 3 terms. So, remainder, when 4 into 4 into 4 into 4 something is divided by 7, the remainders would always be 4 2 1, 4 2 1, 4 2 1. It will go on and on and on in the same fashion, right? Similar manner. Now, it's pretty easy to understand, right? What we are supposed to find out? We are supposed to find out the term number 347 in this pattern, right? This sequence, because this is the first power remainder, this is second power remainder, this is cube's remainder. Then fourth power will again be 4. So, 4 2 1, 4 2 1, 4 2 1, what will be the 347th term? So, we know all we have to do is it's a cycle of 3 terms. So, we will divide this 347 by 3. I think 2 will be the remainder, because again if you know the rules for divisibility, you know for 3 it is sum of digit. So, 3 plus 4 7, 7 plus 7 14, 14 divided by 3, 12 will be divisible, 2 will be the remainder. So, second term, right? Extra terms, so that means some cycles of 3 are completed. Exactly to be precise, it is 115. 115 into 3 will be 345, right? So 115 cycles of 3 terms is completed, but then there are 2 extra terms. 2 extra terms, that means 1, 2. Your answer is going to be 2. So your answer for this question is going to be 2. Fair enough? We can understand this? Right. Of course. Now let us use the similar method to the second question, and now you should be able to do it. So please pause the video. I've already shown you how to get it. Please do it on your own first. Alright. Now I'll remove this. Hopefully you got it. Of course you should have got it. It's not a big deal. Now when this is divisible by 9, so first of all, we know we can actually, instead of 743, we can use the remainder theorem and put the individual remainder there. How will you do it? If you know the rule of divisibility by 9, it is also sum of digit. So 7 plus 4, 11 plus 3, 14 is 5. 14 when divided by 9 gives you the remainder of 5. So this means 5 raised to 187 when divided by 9. Are you getting it? Now what we do? We try to find out the cycle. So if there is only one 5, the remainder would be 5. Okay. Now it is nothing, very easy. 5 into 5, 25. So 25 when divided by 9. What is the remainder? 25 when divided by 9, 7 is the remainder. So 7. Now whatever is the last one, 7 into 5. Are you getting it? 7 into 5, 35. So 35 means 9 3s are 27, 8 is the remainder. Alright. Now whatever is the last term, 8 into 5. We have to keep multiplying it by 5 because this is 5 into 5 into 5. So 8 into 5, 40. 40 when divided by 9, 4 is the remainder. Now 4 into 5, 20, 2 is the remainder. Now 2 into 5, 10, 1 is the remainder. Next 1 into 5 is again 5. That means it's the cycle of 1, 2, 3, 4, 5, 6. It's the cycle of 6 terms. Are you getting it? It's the cycle of 6 terms. Fair enough. And once you know this, all you have to do is to divide this 187 by 6, because we are supposed to find out 187th term in this sequence, right? So 187 divided by 6, obviously 186 will be divisible, only one extra term is there. One extra term means your answer is 5, there you go, right? So that's about it. So are you getting it? This is what remainder theorem and concept of cyclicity mean. If you gel them together, if you mix those concepts, you can answer these questions easily. But now let's talk about the shortcut. Alright. Now even though you are comfortable with this, you feel, sir, we are quite comfortable with this and this is good enough, I am going to give you a shortcut, because in more difficult questions that is going to save lot of your time. So let's understand what is that shortcut method. It is called Totient method. Alright. Now what exactly does this Torsion method mean? It actually gives you relatively prime numbers to n up to n. Are you getting it? What does it mean? First of all, we have to be clear about something. What is relatively prime numbers? Relatively prime numbers means the numbers which have no factor in common apart from 1. 1 is obviously going to be common in between any numbers, but for example, say 3 and 5. Have they got anything in common? No. That means they are relatively prime. Are you getting this? Or you can say 5 and 7. Or you can say 4 and 9. Is there any factor in common? 4 has all the factors like 2 squared, 2 into 2. 9 has 3 into 3. But no factor is common. Are you getting it? Like 9 and 15? Then they are not relatively prime because 3 is common between them. So in other words, if you know HCF and LCM, which you should be, right? In case you haven't, there is also a video, Btitude video on HCF and LCM. Please watch it. Fine, I am giving you another I button for the same. Alright, please watch it. That will help you as well. But are you getting it? For those terms which have nothing in common, that means HCF is 1, right? Those numbers are called relatively prime to each other. Now, so now we know that relatively prime means who have got no common factor. So relatively prime numbers to n up to n. That means, for example, if I take a number as, say, let me take, say 7. Okay. So 7, how many numbers are relatively prime to 7 up to 7. Up to 7 are obviously 1, 2, 3, 4, 5, 6. Alright. And 7 itself. Let's consider up to 7 up to. So 7 itself. Right. So which number is relatively prime to 7? All the numbers, because 7 itself is a prime number. So except for 7, all other 6 numbers are relatively prime to 7. So how many numbers are there? 6. We can make a list and check it out. Fair enough, right? Because 7 is a prime number, so there is difficult to find any relatively prime number with it, unless there is, all the numbers would be relatively prime to it except for itself, right? So it's pretty easy to find 6. What about 13? How many numbers up to 13? Up to 13 means out of 1, 2, 3, 4, 5, 6 up to 13. How many of these numbers are relatively prime to 13? Obviously, except 13, all other 12 numbers will be relatively prime because they would have nothing in common, right? 1 has 1 in common, but apart from 1, right? 1 is always a factor of every number, so apart from 1, so that means for 13 it will be 12 numbers. So are you getting it? Are you getting that for a prime number? For a prime number, what will be the relatively prime numbers up to n? The number minus 1, yes or no? As we saw, because for 7 it was 6, for 13 it was 12. So next time, if we are supposed to find out Totient, are you getting it? Totient means those number of numbers which are relatively prime to that number, up to that number. Fine. So now if we are supposed to find out the totient of a number, let's call it a totient, right? So totient means this. So if we are supposed to find out a totient of a number, if number is prime, then it's pretty easy. Totient of 37 is prime, so it will be 36, right? Totient of 97 is prime, so it will be 96. Fair enough. Because if you try to understand, apart from 97, all numbers from 1 to 96 are going to be relatively prime to 97. Fair enough. So for prime numbers, relatively prime numbers are number minus 1. Pretty easy to understand. Fair enough. Now, what about the composite numbers? How will you be able to figure out the totient of a composite number? For example, 6. Like right now the number is small, we can actually make a list like 1, 2, 3, 4, 5, 6. Okay. Now how many numbers are relatively prime? Obviously 6 is not relatively prime. 1 is relatively prime because 1 has nothing in common. 2 has got 2 common. No. 3 has got 3 common. No. 4 has got 2 common. No. 5 and 6 have nothing in common. So how many numbers? 1 and 5, 2. So the totient of 6 is actually 2. Are you getting it? This is very important. Please be mindful. Please try to understand this. This is going to be a big shortcut to find out the remainder. So it is a bit painful. Take some pain. Okay. Tolerate me for some time, but this is going to help you in such a wonderful manner that you are going to thank me for sure. Alright. So please try to understand this. The totient of 6 is 2. But how to find it out? Alright. Now let us understand, because right now it was there, right? Like when the number is 90, obviously we are not going to check from 1 to 90. It will take a lot of time. So now I'm going to give you a method to find it out. The method is pretty easy. 6, just factorize 6. 2 and 3, right? 2 and 3. Alright. Now tell me one thing. Obviously, these are the factors of 6. So any number which are divisible by 2 or 3 will be relatively prime to 6. Yes or no? Will be not relatively prime to 6. Sorry, it will not be. So we are supposed to find out the numbers up to 6 which are not divisible by 2 and 3. Those are the numbers 1 and 5, right? Which are not divisible by 2 or 3. Getting this? Now how will you find it out? First of all, just try to understand. There are in total 6 numbers, right? And it should not be divisible by 2. Now obviously for every 2 numbers, one number will be divisible by 2, right? So half numbers will be divisible, that means other half will not be divisible. So we are supposed to find out not divisible, right? We are supposed to find out not divisible, because relatively prime means not divisible. So 6 into 1 by 2. And now for 3, 1/3 number will be divisible by 3. That means other 2/3 number will not be divisible by 3. Now 2 is cancelled. 6 into 1 by 3 is 2. There you go. You will be able to find it. Are you getting this? Again, let us attempt the same concept to 90. Now try to understand this. What is 90? Just factorize it. 3 square 9 into 5, 45 into 2, right? 90. So in a way, if we are like there are 90 numbers, up to 90 there are 90 numbers. If I am supposed to find out relatively prime numbers to 90, okay, relatively prime numbers to 90, that means how many numbers are not divisible by either of this? Because if they are divisible by this, then they will not be relatively prime. They would have common factor with 90. Are you getting this? How do you do it? Now it is very easy. Look, there are 90 numbers. Now should not be divisible by 3. 1/3 number are divisible. That means 2/3 number are not divisible. Should not be divisible by 5. 1/5 number are divisible. So 4/5 number are not divisible. Divisible by 2. 1/2 number are divisible by 2. So other 1/2 are not divisible by 2. There you go. Right. Now just try to figure it out. 2 gets cancelled. 5 3s are 15. 6 are 6 into 4. 24. So 24 is the quotient of 90, or in other words, there are 24 numbers in which are relatively prime to 90, up to 90, right? In the first 90 numbers, there are 24 numbers which are relatively prime to 90. Good enough? So now look, I didn't want to give you just a method. You will find this as a method, as a formula in other YouTube videos. But I explained you the reason behind it. I explained you the logic behind it, so that even if you forget, it becomes easy and you don't have to actually memorize the formula. You can understand it something like this, right? You can understand that when it is 3, 2/3, 5, 4/5, 2, 1/2, right? Pretty easy to understand. So this is the quotient. We'll see how this quotient helps, but first we are understanding what the quotient means. All right, now another one, 54. 54 is nothing but 3 square, no, even 3 cube, 27 into 2, 54. So I would say 54 into, now we don't have to think about power. The number should not be divisible by 3 or 2. Forget about power. We are just supposed to understand, identify the different prime factors. The factors are 3 and 2 only. For 54, there are 2 prime factors, 3 and 2. So how many numbers will be divisible by 3? 1/3. So 2/3 will not be divisible, and 1/2. That's about it. 54 divided by 3 is 18. So 18 numbers will be relatively prime to 54. That means 18 is the quotient of 54. Good enough, right? Now let's try to understand how it helps to find quotient in finding the remainder. There you go. Actually, quotient is nothing else but also the maximum length of remainder cycle. Are you getting this? But there is one condition. If divisor and dividend are co-primes. So again, let me try to give you an idea of what does, because you know these definitions are not that easy to understand. You will have to take some time to understand them. I'll make it easier for you by taking an example, because that is where it becomes easier. Rather than understanding the terminology, let us take an example to understand it. For example, now let's try to understand if something raised to whatever is divisible by say 23. All right? All right? Now we know what we know, that we have to find out the cycle. But try to understand, the cycle could be like in the questions that we did, the cycle was in the first question only 3. If you really understand, look here. Okay, let's go to the first question. First question was here. So the cycle was 4 to 1, 4 to 1, only 3 cycle. The cycle of 3 terms. But what if the cycle is of 10 terms or 11 terms or 12 terms? It would simply kill our time. Yes or no? Are you getting it? Right? We'll have to keep calculating it, and we'll have to calculate it till we get the first term again. So here it was easy, 3 terms. Here in the second question, it was not very difficult. 1, 2, 3, 4, 5, 6 terms. So 5 terms, 6 terms, right? 6 terms. It was not that difficult, but still it took some time. Are you getting it? So what if the cycle is really long? It will simply kill our time. Are you getting it? So how quotient help is, the quotient is the maximum length of the cycle. So that means we know the length of the cycle now. We don't have to calculate it. So now try to understand how will we be using it. This is prime number, right? So that means 23, what would be the quotient of 23? 22. That means if something is divisible by 23, the length of the cycle will be 22 terms. Now think about it. Can you afford to make a cycle of 22 terms and waste your time on it? Of course not, right? So this is where it comes into the picture, but this happens only if this rule applies. This totient becomes the length of remainder cycle only if, listen to it, only if divisor and dividend are co-primes. That means if there is 46 raised to something, then don't use that rule. Alright, but if it is 45 raised to something, then there is nothing in common. 45 and 23 are co-primes, then our rule works. This is very important. Now try to understand and try to see the logic and try to see the magic. Okay, how magically we are going to solve the questions. Now have a look at here. Alright, this is the same question we already did with the cycle. I think it was a cycle of 6, but now let's try to divide it by 9, right? Just try to find out the totient of 9. So 9 is nothing but 3 square. So there is only one factor 3, right? One factor 3. So 9 into 2/3, because 1/3 are divisible. That means 2/3 are not divisible. So the cycle would be 3 into 2. Cycle would be of 6 terms. So don't waste your time finding how much long the cycle is. Just with the totient, you know the cycle will be of 6 terms, and as soon as you know the totient 6 terms, you will simply divide 187 by 6, right? So you know 187 by 6 will be 186 will be divisible, 1 will be the remainder. So you, and 743 when divided by 9, you know 4 was the remainder. So 4 raised to 1, 4 or 5, I think 5 was the remainder, right? 5 raised to 1, and your answer is 5. As simple as that. Are you getting this, right? So instead of finding what the pattern is, we can actually use the Torsion method to find the length of the cycle. Let's have a look at the other one. Can you figure it out? I'll just drink some water. Alright. Hopefully it should be easy. Just pause the video. Shouldn't be a problem now. If you understand the Torsion method, should be easy because they are 11, divisible by 11. Now just try to understand. If you don't use the Torsion method, how will you do it? First of all, because it is divisible by 11, you know what to do. You will say 6 plus 9, 15 minus 7, right? 6 plus 9, 15 minus 7, so 8. So this number can be rewritten as 8 raised to 563 when divided by 11. Now you will waste your time finding the remainder, something like this. The first will always be 8. The second will be 8 into 8, 64. 64 divided by 11 will be 9. Then 9 into 8, right? 9 into 8 will be 72. 72 divided by 11, 66 will be divisible. 6 will be the remainder. Now it is 6. Now 6 into 8, 48 divided by 11, 44 will be divisible. 4 will be the remainder. Now 4 into 8, 32. 10 will be the remainder. 10 into 8, 80. 3 will be the remainder. 3 into 8, 24. 2 is the remainder. 2 into 8, 16. 5 is the remainder. 5 into 8, 40. 7 is the remainder. As you can see, 7 into 8, 56. 1 is the remainder. 1 into 8, 8 again. So it's the big cycle of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now anyway, if you know the Torsion method, why would you do this? Right? I would simply do it. If it is divisible by 11, 11 is the prime. So Torsion will be 10. If the Torsion will be 10, that means divide this power by 10, the remainder will be 3, right? So, and this number is nothing but, there you know, right? Divisible by 11, the rule will be, here we can write the, with the remainder theorem, you can simply put the individual remainder. So the remainder will be 15 minus 7, 8. 8 raised to, now when you divide 563 divided by 10, remainder is 3. 8 cube is, now this is divisible by 11, so 8 cube is 512. When divided by 11, the remainder will be 5 plus 2, 7 minus 1, 6. There you go, right? Now here, after making whole big cycle, now you will understand that, okay, the cycle is of 10 terms. So now, where will 563 come? So divide by 10, remainder is 3, and then you will say third term, 1, 2, 3. Your answer will be 6. But you will have to make all that list, and that will simply kill your time. Your answer will be 6, but look how much time it took as compared to how much time it took here, right? We said 6, something like this. So that is why Totient method is very important. It directly gives us the length of the cycle. Fine? Alright then, let's have a look at the fourth question. Again, hopefully this should be very easy now. Fair enough, right? Let's have a look how to find out its answer. Look, 197, so the quotient will be 196 because it is a prime number. So 196, when divided by 196, there is no remainder, 0. That means 3 raised to 0, that is 1. 1 should be your remainder, as simple as that. Pretty easy to understand, right? 3 raised to 0 when divided by 197, what will be the remainder? Now this is 1. 1 when divided by 197, remainder will be 1 only, right? So I hope you are loving it. This is the best method that you can come across with. What about this one now? Okay, divided by 113. 113 is prime 2. So the quotient will be 112, right? All we have to do is to find out the 1682 divided by 112, right? Okay, so 1682 divided by 112 is the quotient. When 24 raised to this will be divisible by 113, right? So 24 raised to this, but what we'll do, we'll simply understand quotient is 112, we'll divide it by 112 into 1, 112, 56, 562, 562, 112 into 5 will be 560, so 2 is the remainder. So instead of whole this, we'll simply put 2 here, right? So 24 square divided by 113, 24 square we all know, yes or no? That much we should be clear, isn't it? 576 or what, right? Divided by 113, 113 5s are 565, so 11 would be the remainder. There you go, right? The answer would be 11. So it is how this can be simple. So otherwise, you know, the cycle would be 112 terms. Can you really write down 112 terms? Of course not possible, right? Alright then, let's move to the next question. Again, you should be able to pause this video and try to do it on your own first. Alright, may I remove this? Okay. Now look, in case you said, okay, 8 is the number, right? If you try to find out the quotient and apply it, you're wrong. You will not get your answer. Why? Because I said the number and the divisor should be co-prime, should be relatively prime. Now here 362 has 2 as a common factor, 8 has also 2 as a common factor. So quotient method will not work. So don't use quotient here. Alright, here quotient method will not work. Here you will have to do it with your normal method, that is trying to figure out the cycle. The cycle will be like 8, 362 divided by 8, 8 4s are 32, 4 is the remainder, 42, 2 is the remainder. So this number actually can be taken as 2 raised to 122 divided by 8. Yes or no? What will be the remainder? That is what this question actually mean, right? Now, how will you answer this? Of course, 2 into 2 into 2, even this 3 power, it would be divisible by 8. There are so many more powers, right? This number actually can be written as 2 raised to 3 into 2 raised to 119, right? Sorry, and divided by 8. Obviously, it will be divisible. That means remainder will be, not this, remainder will be 0 when it is divisible. The answer is this, that means remainder is 0. Fair enough? So here the answer would be 0. So don't use quotient here. Try to understand. Quotient can only be used when the number which we are going to divide and the number by which we are going to divide that number by should be relatively prime. Fine. Let's move on to the next question. What about this one? Should be good. Think about this. Fine. Now, here I am going to give you another trick. I already told you about the negative remainder, right? So when divisible by 11, remainder is minus 7. In other words, that can also be taken as 4, or 4 can also be taken as minus 7. Are you getting this? So if you understand the negative remainder here, it becomes very easy. Try to understand. Now, 189 when divided by 190, all right, the remainder can be taken as, say, 189 itself, because it's not divisible, right? So we'll say it does not divide, so remainder is itself. But in other words, mathematically, technically, you can also say 190 into 1 is 190, 189 minus 190 is minus 1. You can also say the remainder is minus 1. Are you getting this? Fair enough. Now just try to understand this. When I am trying to divide a number by 15, remainder is 8 can be taken as minus 7 also. Remainder of 9 can be taken as minus 6 also. Both are the same things. If remainder is 2, it can be taken as minus 13 also. When a number is going to be divided by 15, in that case, are you getting this? Fair enough. So similarly here, you can take the remainder as 189, but in other words, it can also be taken as minus 1. So, can I say minus 1 raised to 151 divided by 190, right? Because what we do, instead of this number, we put the individual remainder. So, sometimes when the number is near enough, we can take the remainder as a negative as well. That way it is easier to calculate. Now, if you understand, minus 1 raised to anything, right, is either minus 1 or plus 1. If it is odd number of times, if minus 1 cube, then minus 1 plus 1 plus minus minus 1. But if minus 1 square, minus 1 raised to 4, then it will be plus 1 because minus minus plus. So here it is 151, that is odd number. So odd number, so that means minus 1 raised to odd is minus 1 itself. So minus 1 when divided by 190, remainder is minus 1, but we cannot answer minus 1. Mathematically it's there, but practically we don't say remainder is minus 1. What we say, 190 minus 1, that means remainder is 189. Are you getting it? That means if the power was 152 here, then it would be even power here. So minus 1 raised to even will be 1, and 1 when divided by 190, the remainder can be taken as 1. So in that case the remainder would be 1, but in this case remainder is 189. Fair enough. Let's have a look at another similar kind of a question. Please try to do it on your own first. Hopefully it should be very easy. Again it's pretty similar, right? 820, 819. So you say minus 1 raised to 512 divisible by 820. What is the remainder? Minus 1 raised to even power will be 1. So we can put 1 here. 1 when divided by 820, remainder is 1 itself. Fair enough, easy enough, right? Alright then, what about the next one? Think about these two. Fine, think about this. It's very interesting question. Pause the video if you wish, but it's important to do it on your own first. Can we use the Totient? Of course we can, right? Of course we can, because 17 and 25, nothing is common. They are co-prime to each other. We can use the Totient. What will be the Totient of 25? Now we know there is only one factor of 25, 5 square. 5 is the only factor. So that means I'll just remove this. 25 into 1/5 will be divisible. That means 4/5 will not be divisible. We know the method. 5 into 5, 5 into 4, 20 is the Totient of 25. That means this will be the length of cycle will be 20. What we do? So 100 divided by 20. What is the remainder? 0. That means this number becomes 17 raised to 0 when divided by 25. What is the remainder? Anything raised to 0 is 1. 1 divided by 25. Remainder is 1. There you go. Pretty easy. Easy to understand, right? What about the next question? Again, this is very good question. Can we use Totient? Of course we can, because 3 and 34, they have no common factor. Hopefully you did it, right, by pausing the video. If you haven't, let me have a look. How can we do it? Look, 34. What will be the Totient of 34? 34 is nothing but 17 into 2, right? Yes, that's about it. So 16 will be the Totient. If you directly understand, just if they are just two numbers, then you can say 1 less, 1 less. Because ultimately you are going to do the same thing. 34 into, look, 1 less, right? 16 by 17 into 1 by 2, right? So you can say 17 2s are 2 cancel, 16 into 1, that is 16. That's what I said. 1 less 16, 1 less 1. 16 into 1. 16 is the Totient. Are you getting this? So that means now what do we do? 3 is okay. We don't have to write 90. What is the Totient? 16, right? 16. So 90 divided by 16, 80 will be divisible, 10 will be the remainder. So 3 raised to 10 divided by 34. So the same question can be taken as this as well, right? Remainder when 3 raised to 10 is divisible by 34. Now, you will say, sir, it will take lots of time. No, just try to understand. 3 raised to 10 can be taken as, say, we have to get 3's power something which is more than 34. 3, 3s are 9, 3s are 27, 3s are 81. So, let's say 3 raised to 4, 3 raised to 4 and 3 square. Can I write 3 raised to 10 like this? Now, 34, right, divisible by 34. Now, we know 3 raised to 4 is 81. 81 when divided by 34, 34 2s are 68, 13 is the remainder. So, I can take 13 here, 13, 13 and 3 square is 9, right. Now, 13, 13, 16, 169. 169 when divided by 34, minus 1 is the remainder because 34 5 is 170, right. So, this is 169. So, minus 1 into 9 is minus 9. So, you can say minus 9 is the remainder, but we never say minus 9. Practically, we always say 34 minus 9, 25 is the remainder. So, there you go, right. Good enough. So, this is the thing. Look, these are not very difficult questions, right. Very difficult questions can come up in CAT, in staff selection, and I will make a separate video for them. Okay, this is just the common kind of questions that can be asked in any competitive exam. All right, but if you know the trick, it's pretty easy. All right, then what about this one? Again, you can pause the video and try to do it on your own first. I'll simply remove it. Let's have a look. 221. Is it divisible by any number? Let's try to 235. It's not divisible by 7. No. 11. No. 13. 13 ones are 13. Yes, there you go. 13 is divisible by, because if I do 13 ones are 13, 91, 13 sevens are, right. So, it is 13 into 17. Getting it? So, this number is nothing but 13 into 17. What will be the Totient? Obviously, that and 21 has nothing in common. You can use the Totient method. What will be the Totient? 12 into 16. Fine. Even if you do it, it will be the same because it will be 221 into, now how many numbers are divisible by 13? 1 by 13. So, you always write 12 by 13 into 16 by 17, right. 13 into 17 is anywhere 221. So, 12 into 16, that is what I already told you. So, look, the Totient will be 192. Are you getting it? The Totient will be 12 into 16 is 192. Such a long cycle. How can you make it? It will even kill your time. But once you know the Totient method, you know it will be the cycle of 192 terms. All you need to do is 21 raised to, don't put 962. 962 when divided by 192, what will be the remainder? 19 5s are 95, right. So, if I do into 5, 950 plus 10, 960. So, 2 will be the remainder. So, it is nothing but 21 square divided by 221, right. What is 21 square? So, this whole number, you know, it becomes just 21 square. 21 square is 441. You can see it, 441, 441 divided by 221. 221 2s are 242. There will be one more. So, 220 is the remainder. There you go, right. 220 will be the difference between them, 220, right. Had it been one more, it would be divisible, but right now it is one lesser. So, 220 is the remainder. Fair enough, right. So, hopefully you are enjoying this one. Another one. Now, this is even difficult, more difficult. First of all, do you know what does this mean? So, you should be able to understand what is the difference between 2 raised to 3 raised to 2 or 2 raised to 3 raised to 2. Looks similar, but there is a bracket here, there is not a bracket here. What is the difference between these two? If you know it, then you can pause the video and try to do it on your own first. Look, this is obviously 2 cube into 2 cube. So, 3 into 2, this becomes 2 raised to 6, alright. But here, this is 2 raised to whatever this is, 3 square is 9. So, this is actually 2 raised to 9. Getting it? This is 2 raised to 6, 3 into 2. But this is, first you have to simplify this and then 2 raised to 9. Fair enough. Can you answer this one now? 458 raised to 14 raised to 9, 39 divisible by 7. What will be the remainder? Hopefully you tried it. Let us have a look how we can solve this. Alright. So, first of all, we know the Totient of 7 will be 6 because it's a prime number. And first of all, can we use the Totient? If 458 is divisible by 7, then we cannot, but then obviously the answer will be 0 because then it is divisible. Obviously, it wouldn't be the case. 7 6 are 42. Yes, that is not the case. Remainder is actually 3, right? 7 6 are 42, 38, 7 5 are 35, 3 is the remainder. So, the 458 can be taken as 3. Now, 3 raised to, what we do? We don't write this thing. What we do? We always divide the power by Totient. We know the method, right? So, here the Totient is 6. So, I would say what will be the remainder when power, now power itself is this big, is divided by 6, right? So, this will go here and then divide by 7, and what will be the remainder? Are you getting it? Right? 3 raised to, this becomes 458 becomes 3, but power we never write power. What we do? We divide power by Totient, and whatever is the remainder we write here. So, actually in this kind of the question you will have to understand it twice. Once you understand this, now another Totient you will have to understand. First you understood 7's Totient is 6, accordingly you put it here. Now you will have to understand what will be the remainder here, right? That remainder goes here, right? So, you will have to understand, okay, 14 raised to 39 divided by 6, what will be the remainder? What will be the Totient of 6? First of all, can you use the Totient method here? No, because 14 and 6 have got 2 in common, right? So, here you cannot use the Totient method, you will have to simply understand this, you will have to use the normal cycle method. That means 6 2s are 12, instead of 14 you can put 2, right? Now, 2's power when divided by 6, what is the cycle? 1 power is 2, 2 2s are 4, divided by 6, 4 is the remainder. 4 2s are 8, divided by 6, 2 is the remainder again. So, 2 4 2 4, it is just a cycle of 2, right? So, it is just a cycle of 2, 39 when divided by 2, because this is 39, right? Cycle of 2. So, 39 when divided by 2, 1 is the remainder. So, this can be taken as 2 raised to 1, and 2 raised to 1 is 2. Your answer will be 2. So, you put 2 here, 3 square 9, 9 when divided by 7, remainder is 2 here as well, right? 9 divided by 7, remainder is 2. So, the final answer to this question is 2. Fair enough. So, this was a bit difficult question, but maybe in case it is asked, we should be prepared for it. I will take one similar kind of question here. Please do it on your own first, so that you feel more confident about it, and I am actually going to give you an assignment on this as well. So, what I have done is, you can actually go in the video details, fine, there is a link, hit it, download the copy, and please try those sums on your own, fine. I will also make a video on that particular assignment, how to solve those assignment questions. Fair enough. So, first of all, this question, I will simply remove this. How to do it? Just try to understand. First of all, what is the Totient of 11? 10, because 6 and 11 have nothing in common anyway. Now, we put 6 as it is, but in the power we don't put 7 raised to 283. What we do? We divide this power by 10, and what will be the remainder, right? That is what we always do. What will be the remainder when 7 raised to 283 is divided by 10? Now, look, it's pretty easy to understand. In a way, the remainder, even if you do the cycle, or maybe the various ways you can do it, right? Even the cycle will be of 4, because 10, if you use the Torsion method, 10 is nothing but 5 into 2 is 10. So, the cycle will be 4 into 1, Totient will be 4, Totient will be 4. When you divide this by 4, are you getting this? 280 will be divisible, you can take only 3. So, 7 cube when divided by 10, remainder will be, 7 cube will be 343, right? Yes, 343, 343 divided by 10, remainder will be 3. So, you can put 3 here. So, it becomes 6 cube divided by 11. 6 cube is 216 divided by 11. Remainder is, you know the rule, 6 plus 2, 8 minus 1, 7. There you go, right? So, that is about it, fine. This is how you can find the remainders. So, hopefully you enjoyed this, fine. Go back and forth to make sure that you understand all the concepts in their real sense, fine. So, hopefully you enjoyed this one, and if you did, please like the video, please subscribe to my channel, you know those things, right? I don't have to tell you again and again. Of course, I believe that you would be doing it, right? If you are looking to this level, to this extent, right? It's been maybe 45 minutes so far. So, even if after 45 minutes you are watching this, that means you already liked it, and if you liked it, you have to like it, right? You will share it, you will subscribe to my channel in case you haven't, and please hit that bell icon so that whenever I upload a video, you will get the notification in your notification bar and you can learn in the very good manner, right? Because learning will become easy when you watch Btitude videos, as you have seen over the time, right? Alright then, keep watching, keep learning and keep enjoying.